Hello and welcome to It Doesn't Have to be Stuxnet, Attacks on Common Industrial Control Systems. My name is Keith Tomey. Today we're going to talk about attacking industrial control systems that may be not as large as something like Stuxnet or a large power plant, but a smaller organization. So we're going to go through that today. I do want to note that this is pre-recorded, so I won't be able to directly answer your questions as this goes, but I will be in the Discord channel to answer things along the way. And of course, after the fact, we'll be in Discord to answer any questions. I hope everyone's having a great time with the OptiSource ZeroCon. There's a lot of great information in the presenters here, so let's get to it.
So the agenda for today, we're going to go through a quick introduction, of course. Then I want to move into an ICS primer, just to kind of level set some terminology, some common design aspects around an industrial control system and the components. And then we'll talk a little bit about some recent attacks, and we'll kind of analyze those and the common traits of those attacks. And then we'll actually get into an example ransomware attack scenario. So we're going to go from the initial breach point, from a perimeter breach, no credentials, nothing about the organization, right into breaching them from a perimeter, getting access to the internal environment, locating some ICS equipment, and then doing some custom coding in Golang to actually create a ransomware malware to control that equipment, and we're going to control it as an attacker. And then, of course, we're going to talk about how to fix that attack, the things that went on in the attack. So we're going to talk about some mitigation strategies, and then some closing comments, and then we'll be in Discord to, of course, answer questions and talk about this subject further. So I am Keith Tomey. I'm Dude Man with zeros, not O's, on Keybase and Twitter. You can also find me in some other places as well. But those are the two main hangouts that I hang out with my team. I'm a principal consultant here at Optiv on the Attack and Pen team. I've been here almost 4 years. I'm primarily focused on adversary simulations and general consulting, larger contracts and things of that sort. I am an 80s hacker turned wannabe pro. I've been doing this for a very long time. I started programming when I was in 6th grade in elementary. We had, I think, one computer per school in our district, so I would stay after and write little text adventures, and that kind of lit the fire. Into the 80s, got into some more nefarious activities that I kind of continued on wanting to do this professionally, and I've done it here at Optiv for a while now, and I like it. The first half of my life, though, I spent around electric motors, industrial controls at a small organization here in Michigan called Spina Electric. It's a family-owned organization. I absolutely love the folks there. I'm still in contact with them. The president there and I used to go to cons all the time. We'd go to DEF CON, Black Hat. We shared mutual interest in that. So they really allowed me to cultivate that interest and form it into a career for the rest of my life. I have a degree in information systems and cybersecurity from Walsh College. It's here in Troy, Michigan, an amazing college that blends cybersecurity and business. You kind of have to have that for consulting. It's great if you can do all the hacker things and super secret squirrel things, but you have to be able to talk to clients about that and how to fix that. So, and I'm also a reserve deputy with the local county sheriff's office cybercrime unit. Our mission there is primarily child predator apprehension. We give talks to kids at schools and other organizations in the county. Sometimes we assist on other activities that involve electronic devices, but primarily it's child predator apprehension and protecting kids on the internet. So the purpose of this talk really is to just generate awareness. There's a lot of focus in the media recently and different articles and things of that sort around industrial control attacks. So I just wanted to really get some awareness around these, and the fact that it can be smaller organizations that can be attacked as well, not just large organizations. So to get those smaller organizations to start thinking about industrial control system security, and then also to illustrate what an attack looks like. It's a lot of great presentations out there that some folks that I look up to in the industrial control space, but I wanted to really give the audience a view of what an attack looks like. From that perimeter attack, you're going to see screenshots, commands being executed, the equipment being controlled. So I wanted to be able to actually illustrate that, and that's really the primary focus of this talk. And then also along the way to generate multiple opportunities to identify where those things could have been stopped along the way. And then of course, provide guidance and starting points for that mitigation before it happens. So the target audience for this presentation really is going to be organizations that have ICS in their environments. It could be a large organization, small organization. That's really going to be one of the main target audiences. Also, the ICS community, specifically those that may not have security-oriented training or awareness, so they can kind of get a look from an attack and security perspective, what their equipment that they're managing presents for an attack surface. Red teamers, that's some of these systems are really fragile, so you typically wouldn't see this on an engagement to blend with a red team, but there might be some opportunity there for certain things to be utilized. And of course, for the blue team and defense side, to look at these systems and gather some information and choke points along the way that you might be able to spot some activity and stop it before it happens. And then just generally anyone that has an interest in how these attacks happen, whether it's ICS related or otherwise. When we get into the example scenario, there's a lot of things there that would happen up until the point we start looking into ICS that would apply to all organizations. We're going to do that perimeter breach would apply to pretty much any organization, dropping a payload, bypassing AV, EDR systems, stuff like that would apply to anyone, whether you have industrial controls or not. So let's get into the industrial controls systems primer, just to get a level set of some terminology and things of that sort. So what exactly is an ICS or an industrial control system? Well, it's a compilation of different components and processes that are primarily found in industrial manufacturing environments. So anywhere that's making parts, any type of output, whether that's chemical, energy, something of that sort, that's where you'll usually find ICSs. It's comprised of operational technology, the OT equipment, and it's supported by IT. They are two different entities. Organizations need to think of them as two different entities that work in concert to produce that output. When you start blending that and lines get a little bit blurred, bad things can happen, and we're going to show that here in a little bit in the attack scenario. It's a combination of multiple components, so distributed control systems, that's usually a collection of OT within a singular plant or manufacturing location. And then it's also got SCADA devices, supervisory control and data acquisition terminals. Now, a lot of times ICS is thought of as SCADA, where SCADA would be the all-inclusive thing, but really SCADA is a component of an ICS. And really what SCADA allows is operators to kind of monitor and control equipment in that OT space. And then of course, safety instrumented systems, those are super important. That's what will keep bad things from happening in the physical space should something go wrong within the processes. And these are usually made up of things like interlocks and things of that sort that would physically shut these machines down to keep things from happening. It does have human machine interfaces as part of ICS. Those usually are the things that you'll see operators sitting at. It's depicted here in the screen in the lower right that kind of shows the output of these different OT devices and things that they're going to monitor. That's where the HMI comes into play. And then programmable logical controllers, those actually is the brains within the environment. So that really is going to control the inputs and coils that control the OT, the actual physical equipment. Now inputs, just to keep it simple, inputs could be thought of as like a start switch, stop switch. And then coils would be something that would act on those inputs. So you could think of it as a relay that would engage a motor or a pump. Of course, it can get more complex than that. There's input registers and things of that sort that can represent more than an on-off state. But just to keep it simple, that's kind of what it is. It's the brain within the environment. And then the RTU, the remote terminal unit, really is what interacts with that PLC in the OT equipment. So they kind of all work in concert to produce that output within a process. Now, a lot of this equipment and this technology is old. We're going to talk about Modbus primarily throughout this presentation. And that was created, I believe, in 1979. They really didn't care about security then, for the most part. It was an afterthought. It's non-encrypted. It's unauthenticated. There's plenty of things you can do from an attack at the network level and other things to cause problems when Modbus is in play, and other protocols as well. We'll talk about some of those protocols that can cause issues with that. So this is a common ICS component layout that puts all those pieces from the previous slide together. We're going to get a little bit more detailed on the OT side of the layout here in a second, but generally this is how it would look in an organization. First and foremost, you'd have your corporate environment. That's your IT side. That's where you'll find people doing their everyday work for business, workstations, database servers, ERP systems, and switches and routers and things that kind of comprise that environment. And then the OT environment, the ICS, is going to have things in it like the SCADA equipment and the supervisor consoles that are monitoring the OT equipment. There'll be engineering laptops in there that are going to be, or workstations that are going to program the PLCs. And then, of course, usually there's a data historian in there that's going to collect all that data that could then be fed to the IT or other components of the process. That data historian is really important to collect that data, make sure things that are running efficiently, as well as post-mortem. If something goes wrong, there's indicators there that could be investigated. And then, of course, your SCADA server that's going to kind of interact with all that. Now, within the ICS, the production environment has the RTUs and PLCs, and then, of course, the end OT product that actually gets things done in physical space. Here we see the RTU controlling the PLCs, and then those PLCs are controlling the actual physical equipment, a high voltage panel here, and then, of course, there's a VPI tank. We'll talk about that a little bit because that's exactly what we're going to attack in this scenario. Now, there are recognized regulatory standards that are out there that most organizations should be following within one of these different standards to design their ICSs. There's general frameworks, a couple of them put out by NIST, that kind of organize how things should be set up for an OT environment or ICS environment. And that's done for a couple of reasons, primarily for safety and reliability, but also so that there's a uniform design across the board. Now, some of these standards and frameworks can be industry specific. So when you're talking about nuclear and energy, things like that, you'll see it in NERC. TSA has some pipeline security guidelines, and quite recently, CISA has started doing some of these things too. They have a really good feed that they'll put out when there's different threats that are presented within the ICS space. We'll talk about one of those here in a little bit, but there are standards that are recognized and should be followed. Now, this is one of the recommended standards, the Purdue model. This one's pretty popular. It breaks your OT, your ICS environment up into different components and levels. You could think of those as logical in some cases, but also in other cases they're physical. So at level 4 or 5, that's your enterprise. That's where you're going to see your IT space that we kind of looked at in the other slide. And then in the DMZ, you'll have your patch and remote access servers, your application servers. Then you start really getting into the ICS stuff. So the manufacturing zone, those engineering workstations, those historians, and then level 2 is your control area. So that's where you'll see your operator, HMI, and SCADA equipment sitting at. And then as you get further down in the process, closer to physical space, you'll see the PLC and RTUs in there. And then in level 0, you're going to actually see things that move and make things happen in physical space. This is really quick overview of the Purdue model, but this is typically one of the most recommended design models. It keeps things separated for safety reasons as well as manageability. You'll see firewalls along the way that's controlling flow. There really is no reason for Bob in accounting at the enterprise level to be talking to the engineering workstation. And so there's design around that to keep that from happening. When that starts to get gray and things blend, bad things happen. So we're going to look at that here in a little bit and what can happen there. So ICSs do have some common protocols. There's quite a few. This is a real quick overview of some of them. Initially, it was RS-232, 485. That's a serial communication protocol. 232 is a short haul, and then 485 is your long haul. Modbus goes and kind of puts that into a TCP/IP format for networking. It is raw messaging. There's no authentication or encryption or checksums or broadcast suppression, which we'll take advantage of from an attacker standpoint here in a little bit. It operates at the application level for the OSI model, and it uses like a client-server input coil communication model. So typically one client to 247 servers. That gets a little murky in understanding it. Sometimes from an IT perspective, you would think it would be the reverse, but In the OT space or the ICS space, it's client to servers. Then there's distributed network protocol, DNP3. They did release a different version of that does have secure authentication, DNP3 SA. It's primarily in water and electric industries. I've seen that in some of the electric pumping facilities that I've worked with. And then it operates also at the application layer. And then Common Industrial Protocol, CIP. It is vulnerable to denial of service, man-in-the-middle, and replay attacks from a network standpoint. Then we have building automation and control, BACnet. You'll find those usually in HVAC and fire detection systems. Again, I've seen that in an HVAC before. Interesting scenario there. But Profibus and Profinet, that one's pretty popular as well. It operates via that serial protocol. Profinet puts that TCP Ethernet stack across it. There's really no authentication mechanism, however, and attackers can impersonate client PLC nodes quite easily with that protocol. Now, there is Open Platform Communication Unified Architecture, OPC-UA. That one does start to really integrate some good security into it. The communication layer does establish a secure channel with the client server using encryption and signatures and digital certs. It's at the application layer, authenticates the user with permissions that are verified. And it does come with a cost and speed, however. So, if speed's an issue in some of these ICS environments, that may not play. But where people can get away with it, they should look at that. There's definitely a lot more secure than your older Modbus or Profinets. We're going to primarily focus on Modbus throughout this presentation, since it is quite widely used still, even though it's an older protocol. And Modbus really is a series of inputs, coils, and registers. So to try to keep it as simple as possible, coil is read-write. That's what's going to control things in physical space for the most part. You're going to have your switches, which is your discrete input, is going to tell that coil to initiate the physical space movement. You do have input and holding registers, so those are things where you can actually put variables in, so you can see things like temperature, different types of measurements within that within those registers. This is what it kind of looks like within an actual layout. So on the left side, you'll see your input coil, your input registers that's going to control your coil. In this case, it would start a fill valve and a discharge valve. We'll see that in action here in a little bit. And then also Modbus has function code. So this is a series of different instructions you can place within that packet. And there's everything from the read coils. You can read multiple coils at once. Within our attack and our malware that we're going to write, it's going to take advantage of writing different multiple coils at the same time. But I don't want to get too far into this just for time's sake, but it's quite lengthy in the things you can do with one function code that's built into the protocol itself. And you can take advantage of that from an attack standpoint. So this is what the Modbus protocol looks like under a network analyzer, in this case Wireshark. You can see the communication between the PLC client and server comms. And it's important to note, you'll see a lot of different packets back and forth between the two different entities. So you'll have coils being written to, you'll have things being read, registers being written to, things being read. And from an attack standpoint, you have to sever that communication. It's going to want to take precedent because it's already established comms with this other entity. So in our attack scenario, we're going to first denial of service that to break that communication. And as from an attacker standpoint, we're going to take over and start doing our own communication. But just wanted to show kind of quickly under the microscope from a protocol level what it kind of looks like. There's a lot of different traffic back and forth between clients and servers in an ICS environment. PLCs, the programmable logic controllers, they operate under what's called ladder logic. It is a rule-based language, sequential control logic. So the decision flow really is left to right, top to bottom. As you can see here in the illustration, this is one that I actually wrote for our sample malware today that shows those things being conducted in a ladder design format, which is why it's called ladder logic. But essentially, it's controlling what can happen at the same time. Certain things have to be fulfilled. It's a really rudimentary logic design, but it is efficient in the fact that there's only certain states things can have. So works pretty well for that. So that really is the ICS primer in a nutshell. It was super high level. There's so much more. You could spend a talk or two just in that, but I wanted to kind of give a level set so that when we get into these other things, you can kind of understand, what those terminologies are and what's kind of happening behind the scenes. So let's get into some recent attacks now real quickly, just to kind of illustrate what's been happening. Things have been ramping up. So in December of 2016, the Ukrainian electric power grid was attacked by what was a Russian hacking group known as Sandworm. They triggered some power outages in multiple locations, and that started to utilize automated malware to target power devices. So as we start to go through these recent attacks, you'll start to see things really escalating in their SOP and how they're doing stuff. Then in December of 2017, the Ramcode attack was executed. That was again Kremlin linked. It was using Triton Trisys malware that targeted ICSs, and specifically within the ICS, the safety instrumented system, so the SIS, which is inherently dangerous to start attacking that because you can start causing some physical damage in physical space with that. So again, you see it starting to escalate. And then April 2021, we had the Colonial Pipeline attack. Now, this is a little interesting because it really wasn't targeting the OT, it was targeting the IT, but because of the reliance from OT on IT and that partnership, OT had to shut down as a result because it was dependent on it. So that's where we started to see, those different logistic issues happening as a result of ransomware on IT affecting OT. Then recently, CISA released this advisory alert that was illustrating Pipe Dream, which is a malware that's highly sophisticated. It's a framework, really, that is starting to incorporate all the facets of ransomware and things of that sort towards ICS systems. It's targeting specifically Schneider Electric and Omron PLCs, which is using Modbus in some of their in the setup. It is a full malicious ICS framework. With inside of that, it can actually turn PLCs into SOX proxy devices to then pivot into other network layers within the organization. There's all kinds of things in there that are supported. It is a full-on malicious ICS framework, and kind of going to simulate that a little bit on the raw information that we have from the CISA alert. But yeah, it's definitely escalating in ability on what they can do with these attacks. So these attacks do have a commonality, though. They're large in size, notoriety, and value. There's a lot of different motives. Specifically, you see like the Ukrainian attack that's resurfacing again now with the conflict that's going on over there. So it can be geopolitically driven, but also we're starting to see the ransomware effects of it. So people are attacking these systems for money. And it's important to note, which is a large portion of this attack, that this talk is that smaller ICS environments can be just as valuable for an attacker. It doesn't have to be a large pipeline. Anywhere they can make some money at it, they're going to start looking at it. And there is an increased attack surface. Azure and cloud connected industrial IoT devices are starting to show up now. Our team at Optiv, we have a really good IoT team that does this work all the time, and they're starting to see those blends as well from attacks coming from cloud-based surfaces. This is a real quick output for Shodan. Shodan, if you're not aware of what it is, it's basically a series of scanners that run on the internet all the time. They're looking to perform what services are being offered out there from the public internet. Now, from the perspective of Modbus, which is port 502, this is what I found. 25,000 devices were out there, almost 26,000. 3,500 of those in the United States that are directly you can talk to from the public internet. So when we get into this attack scenario here in a second, we had to breach the perimeter and get into the internal environment. But in this situation, if these are legit Modbus devices, we can control them without even having to go to that phase, which is even more scarier. So I wanted to show the metrics here that, this is a serious issue. It doesn't have to be a high level of attack to get to these devices. So let's have some fun. Let's get into the example ransomware attack scenario. It's going to be pretty cool. Hopefully you guys get a lot out of it. Let's get into it. So a quick overview of it, it's going to be ransomware in OT versus IT. As we kind of talked about before, most of the ransomware is in an IT space, but in this case, we're going to actually ransomware the OT devices. It's going to be comprised of an initial breach. This could be a couple different ways: phishing, external services, physical access. In this scenario, we're going to do a password guess on a Microsoft 365 environment. It's gaining in popularity as people go off-prem to start managing their services in the cloud. So that's why we're going to attack this. It's a true method that we see a lot across our testing at Optiv. We're still able to password guess and really do some stuff. So post-exploitation and lateral movement, we're going to do that. I want to note that I did not have to be a domain admin at any time in this scenario. Now, granted, you're probably like, Keith, you designed this lab, so of course you wouldn't. But again, I've been doing this a while. I designed this lab so it's representative of what you would see in most organizations or what I've seen. And in this case, you just don't need domain admin to talk to a Modbus device. It's going to incorporate discovery of IC networks and related services, ICS networks. And then we're going to actually get into the hypothetical ransomware using Golang to target the ICS. We're going to do PLC denial of service to override that ladder logic and establish comms, and then exploit those devices with an integrated C2 using encrypted communications. Now, this malware, it's interesting the way I wrote it is, if communications are severed at any time, it's doing random check-ins with the C2. If it does not see that C2, it's going to immediately go into detonate mode. It can also be triggered from a command from the operator to go into detonate mode, but I put that in as a kill switch, basically. It would have the ability to infect multiple workstations. I didn't do that in here just for time's sake, but once you have a binary, there's a couple different ways you can do it. And then we're going to actually see what would happen if payment's received and if payment's not received by the target victim. In regards to the simulated ICS environment itself, I didn't really have any physical hardware to put together to do this, which at some point I'll probably try that as well. But anyways, we simulated this in a bunch of different virtual machines. It was comprised of some ICS specific software. So in this case, we use OpenPLC. All this stuff here is free, by the way. So you can pull this down and play with it yourselves. OpenPLC really is where you can design the ladder logic and start to set up some simple PLCs. And then factory IO is what I use to actually animate into the equipment that would show the physical devices. Now, the part of the scenario is going to be targeting a vacuum pressure impregnation tank, a VPI tank. And what those tanks do is they're utilized to insulate motor windings with epoxy resin. There's a couple reasons to do that. For the efficiency of the motor itself and the windings. For one, it protects the windings from corrosion, moisture, and contaminants. All those three things can be absolutely damaging to an electric motor winding. It also promotes better heat transfer. Some of these motors, especially high RPM motors, are going to really get hot. So you want to have better heat transfer within those coils so you're not having any burnout situations. And vibration, so it does reduce vibration within the coils. It takes up physical space to make sure those coils are not shattering. Again, when you have vibration in an electric motor or a pump, it's really bad for it. It's going to destroy bearings. You're going to have all kinds of issues. They're going to cause some problems there. And it just overall increases efficiency of an electric motor. So these VPIs are typically connected to PLCs. So they are a perfect opportunity to kind of do a small study on a ICS attack. So that's what I did here in a simulated environment, of course. In the background of the slide, you can actually see a VPI tank that's being controlled by an HMI, and in that cabinet, there's some PLCs and RTUs. So the actual attack overview of this is a typical cloud-based C2 setup structure by an attacker. You'd see this by attackers at all levels, but this is a somewhat basic one. We're going to establish that payload doing some cool activities and establish a C2 with the actual corporate environment via workstation. And then we're going to kind of pivot through some of those firewalls to get to the actual ICS environment itself from an attacker standpoint out somewhere in the world from the public internet. Now, again, all this communication would be across an encrypted channel, which it is in this case too in the simulated environment. We use cloud fronting to kind of hide our location. You can also, with that type of scenario, set up multiple C2 servers that are hidden behind that cloud front that should one go down, the other one's going to kick in. So it does, for an attacker, provide redundancy as well. So the initial breach itself, many organizations are going to Microsoft 365 as they get off-prem to manage things in the cloud. There's a lot of technology that can be rolled out quickly that way, lower cost as far as physical space and physical equipment, keeping things updated and patching and things of that sort. So definitely a big move in the industry that's going to cloud providers for that, even for their infrastructure. So we're going to target that. The name of the company is called Agency Electric. We're going to do password guessing on that, and this particular account that I'm going to identify here is going to be non-MFA, so there's no multi-factor authentication, which would be one of the first things you could do to mitigate. But we start by identifying what Agency Electric is using for their email, just to get kind of a presence as part of our recon. And we use a tool here called Spotter. A good friend of mine, Corey Ham, wrote that. It does a pretty good job of determining what an organization is using for their email. You can do it manually by looking up MX records, but this tool does it really quickly for different hosted providers. So it does identify that it's being used, that the Agency Electric is using Microsoft 365. So we immediately go into a password guess using Go365. Some of our folks that were on our team wrote that as well. Does a really good job at password guessing, and we use pivot proxies to kind of hide our attempts for authentication. Microsoft is getting better at identifying password guessing from the internet. So we have some methods that we use, primarily proxying through different points and timing to stop that attack from being identified. As a result, we do get an access valid login for Robert Lucas using a simply guessable password. We see this all the time in our engagements, and we're going to take advantage of it here. This password does meet complexity. It's long in length. It's got numbers. It's got special characters, but it's common in the fact that it's related to the company. So really got to do a better job at password choices with the employees. So at this point, we have a valid account, but we don't actually have a presence in the internal environment of the client's network. So we need to find a way to do that as an attacker. And one of the ways to do that, specifically in a Microsoft 365 environment, is to take advantage of the Office 365 application platform. You can go through their emails that way. There's Teams in there. You can go through their SharePoint files, things of that sort. So in this case, the attacker goes through the email messages that they have, and they notice that there's a lot of communication with someone by the name of Stephen Kerr, which is an accountant in that organization. So they at this point don't know that there's ICS. They're not specifically targeting ICS, but they do want to get into that environment. So we prepared a payload here using Scarecrow. It was written by Matt Ottelberg, who's an engineering fellow here at Optiv. It takes advantage of some really lethal attacks. He's got a whole talk on that in itself. It's worth checking out, doing process unhooking and avoiding AV EDR telemetry and things of that sort. So we prepare a payload with Scarecrow. We pack that up into a technique that will exploit Visual Studio tools for Office add-ins. So this tool basically can take binaries and have it automatically install into any type of document of your choice. In this case, we'll do an Excel file. Now, the interesting thing is there's a couple of files in that pack, so you don't just have one file that gets executed. And you see here in the internal Teams phish that we did against the target that there's a bunch of files zipped up. So I just simply hid those files that when they got extracted, they run the one file and it still executes. Now, you see in the message that I'm invoking a sense of urgency. It's common in phishing campaigns. Take a look at this. Mr. Knight, which is the president of this organization, wants it to be completed by the end of the day. So that's kind of creating a sense of urgency with Stephen Kerr. I would usually, from an attack standpoint, send that at maybe 1:30, 2 o'clock in the afternoon to lower that time frame so they don't have a decision-making gap there. So that's more apt to be executed. When it does get executed, you see a common warning. There is a way around this as well. I didn't do it for sake of time, but this isn't signed by a known publisher. So in this case, it's going to give the user a warning. But a lot of employees, if not trained properly, will just hit install. And it happens time and time again. We've used it on our adversary SIMs. It still works. Again, you can create signed binaries, however, that will bypass that issue altogether. So in this case, Stephen Kerr gets it. They unzip it. I got to get this done now for Mr. Knight. They see this warning, they hit install, and a beacon gets established to the C2. At this point, the attacker does have a foothold within the environment. So they've landed that C2 beacon, they've got it back, they're on Stefan Kerr's workstation, as you can see in the Cobalt Strike screen there. The first thing they're do is kind of form a SOX proxy that'll allow them to execute their attack tools from their own virtual machine or their own laptop and execute into that environment remotely. We also want to see from an attacker standpoint what the environment looks like. So one of the first things you want to do is kind of find some domain controllers and see what the proper naming conventions are within the domain. And that's what these two commands here after the SOX proxy establishment's doing. It's finding that domain controller and seeing what the naming internal structure is going to be. We then want to get as much information about the environment as we can from an attacker perspective. This is part of the post-exploitation lateral movement phases. So we're going to do some internal reconnaissance. And at this point, since we do have valid credentials and we know what the domain controller is and the domain structure, we're going to pull down in one big pull all the LDAP information. Now, LDAP basically controls contains all of the information about an Active Directory environment. Users, computers, things of that sort, groups are in there. So, some attackers historically would do this in multiple commands. Well, every time you execute that command, it's going to be more apt to be caught. So from an attacker standpoint, we want to do this in batches. We want to do this in one big pull. So we use a tool called Vibe, again, created by one of our people here, Matt Eidelberg, and it pulls all that information down. So then you can make queries against LDAP offline. No, it won't be identified. The only way really you're going to identify that is to see that initial LDAP burst. Really after that, you never see it because it doesn't interact with the environment on the attacking side. Going through that as an attacker, we see that there is some SCADA stuff in here. They've used some common naming conventions we do see in real live environments. So service SCADA would be probably a service account. And we see in the description from Active Directory that is for the VPI tanks, and to get with Bob if you need further information. We do see there's a user account there that's shared. Again, common in ICS environments. This one's called SCADA Operator 1. They may have multiple terminals. They would log in with that to interact with the HMIs and monitor the OT equipment. So at this point, from an attacker, we're like seeing, oh wow, there's ICS in here. This might actually up our ante game so that we can get, further exploit that and create a sense of urgency from the client to get paid. So first we got to find those. So in the last screenshot there on the right hand side, from our Cobalt Strike beacon, we do a quick port scan. We're looking for 502 TCP, which is what Modbus operates on, and we find a device. So now we know there's some things in there live that we can attack. Now, it's important to know if the Purdue model was completely followed in this design, you probably would not see that device because it would be properly segmented. But again, especially in smaller organizations, those things become gray. They need to get updates done quickly. There's usually not someone on staff that manages those devices, so someone outside the organization is managing it. So they have all these weird firewalls that get opened up haphazardly. So that can be done, and this is a fine example of why you should not do that. So this is really what a actual ICS would kind of look like on the scenes as it's doing its normal operation. There's start-stop switches that you see. There's those input coils we talked about before are starting to light up and activate the coils to make things happen with these VPI tanks. And on the left-hand side, you see the actual HMI that an operator might see. You see the different things lighting up, true, false. Again, those are 1-bit values, so that's all it would be is 0 or 1. But this is a typical ICS environment operating here. Now, it's important to note that without actually having access to the HMI to see what things are happening in that ICS space according to what you would see on a screen from an operator, it is hard for an attacker to determine what coils would perform what actions on those devices. So hypothetically, this situation here is where we would use Metasploit's Modbus client and kind of monitor those coil values as things start to happen. So from an attacker standpoint, we start seeing patterns here. Now, the attacker is not going to have visuals on those tanks. It's not going to have access to an HMI, although many times they will access the HMI to be able to get that information. But I wanted to get even deeper in the weeds with this to see how you could tell what was going on. So the attacker here basically monitors the communications with that Modbus device, and they start seeing noticeable patterns. So the first 2 bits are being set at 1. That's really the light coil as well as the actuator coil to begin the pump. And then it goes to an idle position. When the stop or empty button is clicked or pushed, the coils are set at 1 on to get those to start emptying. This is the actual Golang code base. I borrowed GoBurrow's Modbus library just because it was already ready and did all the heavy lifting to address the Modbus interaction. And then the C2 URL is embedded. It's static. It wouldn't typically be done that way, as well as the target string. Those would be variables, but for the sake of time, that's what I did. You can see the different commands in there. Really simplistic. There's functions in there to cycle the tank. There's commands in there to fill, empty, and basically disarm the malware. These debug commands, of course, would be gone, but to assist in programming, I left them in there just so I could demonstrate it. The comms check, of course, is in there if it fails that, or even if it's able to talk to a C2 server but gets the wrong response code, it'll go into det mode. And then I used emojis for the actual command. Just something fun to do. Obviously, a real attacker would use AES encrypted language here, but it was just something interesting to do using some emojis. I've seen that before as bot command structures using emojis. This one, it was receiving the via JSON a eval command, which would then get the malware targeted and spinning up. And then if the operator disarmed it, it would go into the extinguish mode. Yeah, pretty basic code. It took me a couple weeks to put together, off hours, just kind of monkeying around with it. So my point is, it doesn't have to be an APT or a high-level threat actor to put this stuff together if given the right scenarios. I was versed in Golang beforehand somewhat, but didn't really know a whole lot about Modbus and trying to address Modbus devices. So it kind of tells you how quick you can spin that stuff up. This is the actual debug information. So you just kind of give an idea of what's going on when that malware is talking to those devices. So when it gives it that evil execute command, it's starting to fill tank 3. It's filling tank 5, filling tank 0. It's emptying 5. It's filling 2, emptying 2. So it's really random. There is some safeguards built into the code itself, so it stays within certain parameters. Now, when we see the animation of how this is going to go here in a second, it does create some cavitating. I could probably write code to even cause that issue so that rapid increases in pressure and depressurization would cause structure failure in the device. I just wanted to show what the commands kind of look like under the tank, under the hood, between emptying, detonating, things of that sort. So for the first phase of the attack, as we mentioned earlier in the presentation, we do have to sever the existing comms from the PLC to the devices. So we're going to do that with denial of service, since Modbus does not have any protections for that. And the easiest way to do that really is to do a ICMP flood, and we do that targeting the PLC device itself. And as you see, hitting the stop button, things of that sort, it's not having any response. You don't see anything on the HMI. At this point, a full denial of service has been executed to the PLC, and we can then attack it with our malware. The stage has now been set to actually conduct the attack. So as the attacker, the first thing we're going to do is upload and get that compiled malware that we wrote in Golang onto Stefan Kerr, which is an accountant's workstation. So we use our existing C2 beacon from Cobalt Strike to do that. Now, of course, most attackers are not going to drop binaries on disk. You typically want to, create some other process. I would probably want to do a driver install and make this an actual driver, because that's going to give you a lot of things. Primarily, it would be persistence, so that the device would always have that on there when it was rebooted and things of that sort. But for the purpose of this example, we just created a binary. It was called Waning Rain. I think I used one of the 3-letter agency naming tools to do that. So it's up on the victim's box. So we give it the ransomware arm command from our C2, and that basically is going to tell it to start executing against those VPI tanks. Now, we'll see within the process itself here that, it actually loads into memory. It is executing. We see the waning rain process, PID 6776 running. Again, that would be usually hidden. It would be named something obscure or into another process to run that. But I wanted to make sure that everybody could see how that's illustrated. So the ransomware starts to execute. Now you'll start seeing these VPIs filling. Now it's fluid here, but typically it would be pressure to get that resin into. And you start seeing the different coils lighting up randomly. You're going to start seeing the valves filling randomly, and you notice the inputs are not changing. That's because those are not needed. The attacker's code malware is controlling those coils at this point, and it will continue to do this until either the extinguish command is given by the operator, the attack operator, or it is losing comms with the C2, in which case it will detonate all of them. We will demonstrate that here in a second, but I wanted to show some of that cavitation. So now the money has been received from the victim, and the attacker has a kind heart for a change and says, okay, let's disarm this and remove the malware from all affected workstations. So it issues the command to all tanks to disarm, which thereby decreases pressure in the tank and successfully empties them. Takes a little bit, of course, to get all those emptied, but that's essentially what it's doing. Everything gets returned to a safe state. And if it loses comms or the attacker does not get paid within a certain time frame, they set detonate all. And that's exactly what's happening here. It's just going to continuously fill until an overpressure exists. Again, that PLC situation would denial of service, any type of mechanisms that are there to control this. If a safety instrumented system was implemented, that would be bypassed by other methods as well. So at this point, yes, they could shut off the machines, but in some cases, like nuclear energy, can you just shut something off and not affect something? Usually, some of these systems have to continuously run, or there's going to be other repercussions. And at that point, things get ugly. Safety instrumented systems fail. Things explode, and it gets down the line that way. So that's the attack. Again, simulated environment. There's a lot of hypotheticals there, theoreticals, but I really did want to show what it would kind of look like and give an illustration from an attacker perspective what it might look like. But let's talk about how to fix some of that, how some of those things could have been stopped along the way. So again, just to recap what the attacker did, utilize the potential username list to perform password guessing in the M365 environment. They did identify one guessable password. They performed an internal phish via Teams to deliver a malicious payload in the form of an Excel document and get a C2 session with a beacon so that they could gain access into the environment. And then utilize that C2 to further reconnaissance and identify those ICS protocols and equipment in place, and then developed and launched that malicious malware to target the ICS equipment. So interrupting this attack, let's look at each phases of the attack itself, and then we can kind of point out things there that could have been done to possibly stop it. So from the password guessing, the use of a password that includes the company's name, although we still see it a lot, it's common, should not be done. It's just something that's going to always be attempted by an attacker, whether it's low level or high level. Should not be there. The 365 access without MFA being required is another one that should be in place. So even if they guess that password, they're going to be required to have that multi-factor authentication confirmed before they could actually access the account from the public internet. And then gaining the foothold, that phase with using that internal phish via the Teams chat. Again, that comes down to employee awareness to recognize those potential phishing attempts. Why would that person be doing Teams to send a zipped payload and asking them to handle that right away. That might be suspicious. I don't, from a hypothetical standpoint, maybe that does happen all the time for some interaction with an inside. But again, need to train employees to assess that and to be able to recognize those potential phishes and respond accordingly. And then from the malicious payload drop itself, need to have applications configured properly so that they can be containerized. That application whitelisting would certainly be in place. That certain things can only be executed. And again, the employee perspective of training them to assess that warning box and not install, even though it's trying to tell them this is unsafe, don't do it. Most employees will do it out of habit. So again, got to train the employees. Establishing that C2 beacon, there should be a proper configuration and installation from a full AV EDR stack in place, multiple ways depending on products to make sure that's done from a defense in depth perspective, but that needs to be done there. Just performing baselining under normal environment behavior so that you can, from a defense perspective, spot abnormal behavior is definitely key there. And then routinely monitor and review endpoint AV EDR logs and traffic logs that might indicate potential malicious activity. We see it all the time in our adversary SIMs where they might be logging, but they're not actually reviewing those logs, or the review of the logs is insufficient or time delayed. So, the different components might be doing their job from a technical standpoint, but they may not get an alert to the SOC for an hour. That's not going to do any good in this case. From the post-exploitation and lateral and vertical movement perspective, spotting and monitoring those domain controllers for increased burst activity for LDAP queries and different types of commands that might be executed from a user perspective. We did it under that initially compromised an account. Is there a reason why that particular user or even Stephen Kerr would be wanting to do LDAP queries like that? Probably not. So that type of activity that's out of the norm, again, goes back to baselining, but yeah, that needs to be monitored and looked at. And then the targeting of the ICS itself, port scans for TCP 502, in this case Modbus, those protocol communications should be monitored and deemed as suspicious on the network, specifically if it's coming from an accountant's workstation, right? There's no reason why that should be going on, or none that I can think of. Properly segmenting the zones to keep OT and IT separated. In this case, that got a little murky. There's no reason why an accounting box should be able to see into the ICS space itself to see any OT. And utilizing security-focused ICS protocols. Now, this one's a little more tricky. You can't just say, hey, let's re-outfit everything that's Modbus with something more secure, because there's a lot of proprietary things in place. B, it costs a lot of money. Even if you can find equipment, they'll accept those types of re-outfitting. So, but if you can specifically, certainly do it. Then the achieving the goal part of it, are executing those malicious payloads. That should be application whitelisting. There should be no reason to execute those weird binaries that were on disk. And again, goes back to AV EDR, checking that out and monitoring it. And then also monitoring different communications to PLCs from and to internal, external destinations. Again, goes to that segmentation. There's no reason why that box should be talking to any of the PLC equipment. And then for sure, incorporate threat intel that can keep you informed of the latest attacks about within your infrastructure as a whole, but also ICS. That's a whole special animal unto itself. So making sure that you're getting good threat intel into those types of attacks and how they're evolving, and different SOPs and methods, certainly something that should be going on. Denial of servicing of the PLC itself, that goes to, again, you just utilizing secure ICS protocols. Not always possible because of the reasons we've stated, but certainly if you can do it. Make sure that firmware is kept up to date. Again, this isn't like patching Windows. You can't be patching ICS equipment all the time. If it's even available, you can't, interrupt a manufacturing process to be able to update these all the time, especially around up here in Michigan, where we're doing a lot of automotive work. Just in time is a big deal. We can't be taking lines down because every second it's down, we're missing thousands and thousands of dollars. And then, of course, properly segmented zones, again, would keep the ability from attackers to actually target those PLCs. And then from a physical destruction of equipment perspective, we want to ensure that that proper segmentation and design and testing and maintenance of safety instrumentation systems is performed. That's your last ditch effort there to protect people from getting hurt. So that needs to really have a specific set of focus onto itself within your ICS design perspective. Ensuring and management and patch management policies and procedures exist and are adhered to for everything, including ICS. Many times ICS is left out of that. And again, can be tricky because of the nuances within ICS and availability of updates and equipment and things that are in place, but it should be for sure looked at. And then lastly, ensuring that proper incident response plans are in place. And it should be communicated and trained on and rehearsed and reviewed by all personnel that would be involved in that. So that spare parts can be procured, you can minimize downtime, and most of all, prevents physical harm to anybody, to make sure that incident response is handled from an emergency perspective. So closing comments. Thank you for attending this talk. Hopefully you got a lot out of it. A lot of these different things that we talked about, we could spend an entire presentation or a few hours in a workshop just talking about some of those things alone, but wanted to give everyone a bird's eye view of how things are going in the ICS space and kind of give you a look behind the curtain of what might happen hypothetically from an attack perspective. So I will be in Discord to answer any questions. So go ahead and I'll stick around there for as long as folks want to ask. Otherwise, have a great rest of OptiSource ZeroCon, and thank you for coming.
Hi, I'm John Quadrino on the attack and pen team under threat. I just want to say something I'm grateful for and I really enjoy on our team is just how open everybody is. When we come up with new TTPs or new tools, people want to show off, share their skills, and teach others.
Hi, my name is Savannah Lazera, and I'm on the Attack and Pen team under Threat Management at Optiv. And I would say the things that I love the most about working on our team is the collaboration that we have with each other. We're constantly sharing new ideas with each other. We're constantly building out documentation for new attack chains. And I would say those are really big things to kind of help grow a team skill and make sure everyone's kind of at the same level.
Hi, my name is Zach Stein. I'm on the Attack and Pen team under Threat Management at Optiv. And my favorite part about working on this team is how we all work together with each other. Whether it be collaborating on an engagement or research new techniques, there's always someone there to A, have fun with, and B, learn new things from.
Hi, my name's Heather Hall. I'm on the demand and delivery team under threat. The thing I love most about my team is how we are all equals. My peers are all willing to listen, help, and take on challenges right next to me.
Hey, I'm Ari with Optiv's Attack and Pen team. Why do I love working for the Attack and Pen team? Because it helps me win from within.
Hi, I'm John Quadrino on the attack and pen team under threat. I just want to say something I'm grateful for and I really enjoy on our team is just how open everybody is. When we come up with new TTPs or new tools, people want to show off, share their skills, and teach others.
Hi, my name is Savannah Lazera, and I'm on the Attack and Pen team under Threat Management at Optiv. And I would say the things that I love the most about working on our team is the collaboration that we have with each other. We're constantly sharing new ideas with each other. We're constantly building out documentation for new attack chains. And I would say those are really big things to kind of help grow a team skill and make sure everyone's kind of at the same level.
Hi, my name is Zach Stein. I'm on the Attack and Pen team under Threat Management at Optiv. And my favorite part about working on this team is how we all work together with each other. Whether it be collaborating on an engagement or research new techniques, there's always someone there to A, have fun with, and B, learn new things from.
Hi, my name's Heather Hall. I'm on the demand and delivery team under threat. The thing I love most about my team is how we are all equals. My peers are all willing to listen, help, and take on challenges right next to me.
Hey, I'm Ari with Optiv's Attack and Pen team. Why do I love working for the Attack and Pen team? Because it helps me win from within.